Hello and welcome to everyone watching this video. Today we're diving in a fascinating and crucial topic, how investigators are able to collect and package evidence at a crime scene. Whether you're studying criminal justice, forensic science, or simply you're curious about the field, this video will provide a clear overview of the methods used by professionals in order to collect and package evidence found at the crime scene. So we're going to talk about different types of physical evidence, for example, like fingerprint, shoe marks, hair shaft. Also, we're going to talk about bullet calibers and many more. So, in any criminal investigation, physical evidence plays a crucial role in determining the facts and linking a suspect to the crime. Talking about physical evidence as a definition is any item found at the crime scene that can establish facts about the crime. This includes fingerprints, footprints, handprints, cut marks, tool marks, body fluids, and many more. Often, when found in very small amount, we refer to this as trace evidence. Each piece of evidence can be a powerful tool in understanding what happened, but its importance lies in how it is categorized and interpreted. Let's start by discussing the two main categories of physical evidence. So we have the class characteristics and the individual characteristic. The class characteristics are traits that allow us to compare any item with a group rather than a specific object or even individuals. These traits include things like the size, the color, or manufacturing patterns, and even more. For instance, a bullet's caliber, a general shoe mark, or a hair shaft can be compared to a group of similar items, but they cannot yet be linked to one specific source. Some common examples of class characteristics include the caliber of a bullet, the general shape of a shoe mark, the soil sample, or a hair shaft, which can tell us broad information like soil type or hair color. Additionally, to blood groupings such ABO types, which can help narrow down the group an individual belongs to, but don't give us a unique identifier. Talking about the class characteristics are useful for narrowing down possibilities, but don't offer the same level of certainty as individual characteristics. Now, moving on to individual characteristics. These characteristics allow us to match an item to a specific object or person, either including or excluding them from the investigation. For example, fingerprints are the classic example of individual characteristics. No two individuals have the same fingerprints, making them incredibly valuable in forensic investigations. However, twins might have the same fingerprint. Now, when talking about individualization, which is the examination of individual characteristic, is one of the major goals of forensics. For instance, when we say that a fingerprint came from a particular person, it's powerful in evidence. Um, Also, blood samples with unique DNA profiles or mechanical fits, also known as fracture matches, where two broken objects can be physically matched together, also fall into this category. Mechanical fit is a unique type of evidence. Imagine a situation where a tool breaks and pieces are left behind at the scene. If we later find the original tool and can match the broken pieces to it exactly, This can conclusively prove the connection between the tool and the crime scene. Now, talking about cross-contamination, you have to know that with physical evidence, there's a risk we must always be mindful of, which is the cross-contamination. This issue is directly tied to Locard's principle of exchange, which tells us that every contact leaves a trace. So, cross-contamination happens when evidence from one source is transferred to another due to poor handling practices, like using the same gloves or tools for multiple items of evidence. This can severely compromise the integrity of the evidence. So, crime scene technicians must take extreme care to prevent contamination by isolating each piece, and I repeat, by isolating each piece of evidence and using appropriate collection techniques. Moving forward, we're going to talk about fingerprint. Fingerprint evidence is one of the most common forms of evidence collected at a crime scene because fingerprints provide individual characteristics and they are analyzed by comparing the rich details and the minuted from the print found at the crime scene to a known print. I want you to know that fingerprints are made up to 98% water, and the remaining 2% consist of substance like grease, oil, salts, and amino acids. Fingerprints pattern fall into three main categories. We have the loop, the whorl, the arches. Now, if you look at this slide, you can see that the loop okay. If you look at this slide, you can see that the loops making up about 65% of all patterns, the whorls, which are about 30%, and the arches are the rarest, making up about 5% within these basic patterns. And also, there are subdivisions like plain arches, dented arches, ulnar and radial loops, and several types of whorls. Fingerprints can appear in three forms at the crime scene. We have the latent print, which are invisible and created by the body's natural secretions. We have the patent prints, which are visible due to the presence of a contaminant like blood or grease. We have also the plastic print, which are impressions left in soft surfaces like wax or clay. Each of these types of fingerprints provides valuable information when properly collected and analyzed. Now, beyond fingerprints, serological and biological evidence can be critical in investigation because biological materials like blood, semen, hair, and skin cells can provide both class and individual characteristics. For example, while a blood type might tell us the group someone belongs to, a DNA profile can uniquely identify a person. The collection of biological evidence requires extreme care to avoid contamination. For instance, DNA from first responders or crime scene technicians can accidentally be deposited on an item of evidence. To prevent this, items must be handled with sterile tools, and technicians should change gloves frequently. Now, biological evidence, such as blood stains, must be collected carefully. For wet stains, the evidence can be absorbed onto sterile cotton swabs and allowed to dry before being packed. Dry stains can be rehydrated with distilled water and then swabbed for collection. In some cases, stains are scraped off surfaces if they cannot be easily removed. It's really important to know that paper is often used for packaging biological evidence because it prevents contamination and allows the sample to breathe, which is essential for preserving DNA. Finally, we come to trace evidence, those tiny fragments that often go unnoticed are trace evidence. Trace evidence can include um, fibers, small glass particles, or minute amounts of blood. The question we need to ask about trace evidence are, what is it? Is it natural or man-made? Where did it come from? How common is it? Can it be linked to a single source? Answering these questions help build a strong case based on the evidence we collect. To summarize, physical evidence, whether it's a fingerprint, a fiber, or a drop of blood, plays a critical role in forensic science. The way we categorize, collect, and analyze this evidence determines its value in a criminal investigation. Proper handling and careful attention to contamination are key to ensuring that physical evidence helps us uncover the truth. Now, we're going to focus on the analysis and collection of trace evidence, specifically hairs, fibers, glass, and other forensic evidence such as soil, paint, and gunshot residue. Let's get started by hairs and fibers. Hair evidence is crucial in forensic investigation due to its unique structural characteristics. By examining the diameter, scales, medulla, cortex, and pigment of hair, we can compare it with the known sample. As you know, guys, a human hair analysis can reveal species, race, and even the body area from which the hair originated, such as the head, the pubic, the facial, or the auxiliary hair. Mitochondrial DNA can be extracted from the hair shaft, but nuclear DNA is more likely to be detected when hair is in its early growth phase. Fibers, like hairs, are classified based on their origin. We have the natural fibers from animals or plants. We have the synthetic fibers chemically produced. We have the semi-synthetic fibers. This type is derived from natural materials modified by chemical processes. And the collection technique is really important here. A high-intensity directional light source, such as an alternative light source known as ALS, helps reveal hairs and fibers by casting them into relief. Using forceps or adhesive tape lift or vacuum methods can effectively gather these samples, although each has its drawbacks, such as collecting extraneous debris when vacuuming. When sampling hair, control samples must also be collected from suspects or victims with 50 full-length scalp hair and 24 pubic hairs typically required for a representative sample. So as you can see here, guys, the tape lifts technique, the vacuum are really good methods to collect hair evidence. However, these two techniques have also disadvantages because you can collect a large number of fibers and other loose debris, as well as target fibers. Now, moving forward, we're going to talk about glass evidence. In crimes involving glass breakage, like burglaries or assaults, forensic analysis focus on glass type, comparing glass fragment to known sample, the direction of force, which is evaluating radial fractures to determine the direction of the applied force, and also the sequence of force in case with multiple bullet impacts, determining the order of shots based on intersecting radial fractures. Glass evidence can be found on suspects when they are in proximity to the point of breakage. As the glass fractures, it creates a glass cloud of micron-sized fragments that can be found in hair, clothing, and shoes. Other types of trace evidence, like paint, okay, paint evidence, particularly in hit and run accident, involves the collection of samples from cars or walls. The composition of paints include binders, pigments, solvent, and additives, as you can see in this photo, and is classified according to its automotive finish layer. Example, if we have electro coat primer or base coat. Now talking about the soil evidence varies significantly due to its mix of inorganic and organic components. Collection from crime scenes often requires sample from multiple contact points, such as where participants walked or where vehicles passed. Now we're going to talk about the gunshot residue. The GSR analysis seeks to identify particles containing antimony, barium, and lead, typically found after a firearm is discharged. The residues can be collected from the shooter's or victim's skin, clothes, or the surrounding environment. GSR evaluation utilizes a scanning electron microscope, known as SEM, to locate unique fused particles containing all three elements. While GSR collection, it's recommended to collect every single evidence related to a shooting case, whether it's a weapons, cartridge cases, victims-related items like cloth, suspects items, and other shooting event-related items. It's really important that there is so many factors affecting the GSR presence. First, the distance from shooting point, the sampling, and the number of shots fired, the time elapsed since shoot, the surfaces washing, the environment, open air, and the surface. Moving forward, we're going to talk about ballistics and firearms. Firearms evidence includes both the weapon and the ammunition components, such as the bullets and the cartridges case. Firearms identification involves the use of comparison microscope to match tool marks or striations on bullet to a specific gun. Now, when it comes to serial number restoration, the technique used, such as using the technique used are the acid solutions to reveal filled off numbers and also key components of firearms analysis. Final thought, in every instance, maintaining the integrity of the evidence is paramount. Proper packaging, contamination prevention, and careful handling of trace evidence ensure its reliability in court. These foundational principles form the backbone of forensic science, allowing us to reconstruct events and link suspects to crime scene. Thank you so much for watching this video, and I'm happy to take any questions. And kindly leave your questions in the comment section.